So if we first kind of break down what these are, kind of to refresh our memory, when we find a mean, it will generally be from sample data. So we call it a sample mean. And this just describes the average of the data set. And most likely we're familiar with how to find an average. We look at taking the total values, add all the values together, and we divide by the number of values we added together. There is some notation that we want to be familiar with. So a mean, a sample mean, is described by x bar. And so x bar is a notation for sample mean. Anytime we see this, it represents a sample average. And that is the sum of each x value, or sum of each value in the data set divided by the total. That will be our sample mean. And a mid-range, which is more likely new for us. So the median, we know that is the value that's in the middle of the data set. It divides the data set into two equal portions. So anything below the median is in the bottom 50%, and anything above the median is in the upper 50%. And of course, the mode is the value that occurs the most, it's most frequent. For our mid-range, the mid-range is best described by taking, it's the midpoint. So it's the value in the middle of the two extreme numbers, the very largest number and the very smallest number. So to find the mid-range, we look at whatever the highest value is plus the lowest value, and we divide that by 2. And so these four values help us describe the data set as far as what the center might be. Now, in the previous unit, in Unit 1, we did talk about histograms, and so that information has not left us. So I wanted to bring back this image from before and kind of talk about how it applies to this unit and this chapter specifically when we look at measures of center. So for any bell-shaped distribution, any distribution that's approximately symmetric, we look at three things being true, and those three things are that the mean and the median and the mode are approximately the same value. So any distribution that takes on this shape that's approximately symmetric or roughly bell-shaped, we look at the mean, median, and mode being roughly the same value, and they should be located near the center of the data set. For a distribution that's negatively skewed, we look at the fact that the mean is actually a lower value than the median, always. And the mode, typically, if we don't have access to the data, if all we have is the histogram, we generally look at the mode being in whatever the highest bar is. So in this case, the mode will fluctuate depending on where the highest bar is for the frequency. But in any distribution that's negatively or left skewed, then the average is going to be a lower value than the median. So in this case, for the example of this distribution, I'm estimating the average to be around 20, and the median possibly could be around 22 or 21. And so we'll look at an example of ungrouped data where we find the information, and then we'll create a distribution to kind of see that property. For positively skewed data, again, the mode will occur in the highest location of the graph for that distribution, and the mean will be a greater value. So in this case, our mean that I'm estimating for this distribution is going to be, let's say, roughly 9, whereas the median is going to be lower than that. If we look at the scale here on the x-axis, if I estimate the median for this particular distribution, just for the illustration purposes, because every single positively or right skewed distribution is going to have this same property, that the mean is always greater than the median. And so we're going to see that in the distribution that we're going to look at here in a little bit for an example. So for our first example, we have some celebrities who are non-living and their current top earnings, so based on royalties and estates, and we want to find the mean, median, mode, and mid-range for the data set. And this is univariate data because it only represents one thing, and that is the top earnings for non-living celebrities. And we want to comment on the skewness. So first we look at, well, how can we find and describe the mean Well, the mean is just an average. So to find that average, I look at, well, what is the sum of each of those numbers divided by the total? So if we were to add all these values together, and there's 13 values here, I believe we get 247 when we add them up, divided by 13. 19 would be our mean, but because the values are millions, we want to make sure we retain that same information, so 19 million would be the average. So that would be the average top earnings in royalties or estate earnings for these sample of non-living celebrities. Now for the median, to find the middle value, generally we want to be able to locate the value in the middle. So for most people, depending on the data set, they may use a technique where they go through and they start marking off values from each end until they get to the center. And so that's essentially what I'm illustrating here, that if I mark one value off from each side until I get to the center value, that's going to be my middle. And I know that's the middle value because there should be an equal number of values below it or above it and below it. So in this case, if I say this 10 is in the middle and there's 13 total values, then I would expect one of them is the middle value. So that would remain 12 values to be distributed on an equal number on the left and the right. So in this case, there are 6 above it and 6 below it. So my median would be 10 million. And for my mode, it's whichever value occurs the most. Now, several values repeat. So there's 2 10s in the data set, there's 2 8s in the data set, and there's 3 7s. And we want the one that repeats the most. In this case, it would be the 3 7s. So 7 million would be our mode. For our mid-range, which is like a midpoint, we look at the largest and the smallest value. I take that value, add them together, divide by 2, and that's my midpoint value, which is 28.5 million. So we take this information and we think about, well, how can we comment on the skewness of the distribution? Mainly, we're going to look at the mean and the median for that. So if my mean is $19 million and my median is $10 million, since the mean is a lot higher than the median, then that is going to create a distribution that will be skewed to the right. And I'm actually going to show you how that looks here in a moment.